Okay, so you've got these two things in system design, a load balancer and an API gateway. On the surface, they seem pretty similar, right? I mean, they both sit in front of your services and they both route traffic. So what's the actual difference? It's a really important question, and today we're going to break down these two unseen heroes of the web.
So here's how we're going to break this down. We're going to tell a story, really. First, we'll look at the problem of just having too much success and how the load balancer comes to the rescue. Then we'll dive into the organized chaos of microservices and see why the API gateway was invented. And finally, and this is key, we'll see how they're not enemies, but actually best friends, and pull out the most important things you need to remember. All right, let's kick things off with a problem that, let's be honest, is a pretty good problem to have. Your app, your website, whatever it is, it's a huge hit. It's gone viral. But now, your single server is just getting hammered. It's on its knees, it can't keep up. So what do you do now?
You've basically got two choices here. You can scale up. That means you just buy a bigger, beefier, more expensive server. But, there's a ceiling to that. Eventually, you can't buy a bigger one. The other option is to scale out. Instead of one big server, you add a bunch of smaller, regular servers. And that is how pretty much the entire modern web works. But it creates a brand new problem. Now that you have all these servers, how do you decide which one gets the next request?
And that is where our first hero enters the scene, the load balancer. You can think of it like a traffic cop for the internet. Its whole job is to stand in front of all your servers and direct the incoming requests, making sure nobody gets overwhelmed and everything stays running smoothly.
So at its core, a load balancer is all about one thing: reliability. Its main mission is to just spread the work out, keep your application up and running, keep it fast, even when you get a massive spike in traffic. It's also constantly checking on the health of your servers. If one of them goes down, no problem. The load balancer just stops sending traffic there and reroutes it to the healthy ones. Pretty smart, right?
Okay, but how does it actually decide where to send everything? It's not just random. It uses different strategies or algorithms. The simplest one is called round robin. It's kind of dumb, but effective. It just goes down the list: server 1, server 2, server 3, and then starts over. A little smarter is least connections. It looks at all the servers and sends the new request to whichever one is the least busy at that moment. And then you have stuff like IP hash, which is really clever. It makes sure that you, as a user, always get sent to the same server. That's super important for things like keeping you logged in or keeping items in your shopping cart. Now, this is where it gets really interesting. Not all load balancers are the same. They work at different levels, kind of like having different levels of security clearance. You have L4 or layer 4 load balancers. These are the speed demons. They only look at basic network info, like IP addresses and ports, and they make decisions incredibly fast. Think of them as sorting mail by just looking at the zip code. Then you have L7 or layer 7 load balancers. These are the brains of the operation. They actually open the envelope and read the letter. They can look at the URL, special headers, cookies, and make really intelligent routing decisions based on the content of the request. They're a little bit slower because they're doing more work, but they're way more powerful.
So, problem solved, right? The load balancer is handling all our traffic, our app is stable, we're good to go. Well, for a while, yeah. But then, the way we build software started to change, and this new trend introduced a whole new kind of, chaos.
Think back to the 2000s. We built what we call monoliths. One giant application, one big block of code that did everything. It was simple to understand. But then, in the 2010s, the microservices trend exploded. We took that big monolith and sliced it up into dozens or even hundreds of tiny independent services. This was great for letting teams work independently, but it created a total nightmare for the apps trying to talk to them. The front end now had to know the address for the user service, the product service, the payment service. It was a tangled mess. And it wasn't just a connection nightmare. A second huge problem popped up. Every single one of those little microservice teams was writing the exact same code over and over again. Code for authentication, code for logging, code for making sure users didn't send too many requests. It was a massive waste of time, and worse, it was super inconsistent from one service to the next. Okay, so how do you fix that mess? How do you bring order to that microservice chaos? Well, this is where our second hero comes in. We needed a single, clean, official front door for the entire system. And that front door is the API gateway. Now, it's really important to understand that this is so much more than just a traffic cop. It's more like a highly skilled security guard, concierge, and translator, all rolled into one. It doesn't just pass traffic along.
It inspects it, it secures it, it can even change it, all before your backend services ever see it. It becomes the central command center for all those things that every service needs. So let's follow a single request on its journey through the gateway. First, it hits the gate. Step 1, authentication. Are you who you say you are, and do you have permission to be here? Then, step 2, rate limiting. Okay, you're allowed in, but you've already made 100 requests this minute, so you need to slow down. Once it passes those checks, step 3, routing. The gateway looks at the URL and knows, this is for the user profile, so I'll send it to the user service. It can even do cool stuff like protocol translation. Maybe the outside world speaks one language like REST, but internally your services speak something else like gRPC. The gateway handles that. It can even talk to multiple services and stitch their answers together into one single response for the client. All that heavy lifting is done right here, so the microservices can just focus on their one job.
So you might be thinking, okay, do I need a load balancer or an API gateway? Is it one versus the other? And the answer to that is a huge emphatic no. In any serious large-scale system, they aren't competitors. They are partners.
I love this quote because it just sums it up perfectly. They're not competitors, they're partners. The load balancer handles the raw traffic. The API gateway enforces the rules. One manages the crowd, the other checks the tickets and IDs. They solve two different problems, but they work together beautifully. And here are a few real-world ways you see them working together. The most common pattern, pattern 1, is you put a load balancer in front of your API gateway. Why? Because your gateway is now a critical piece of your infrastructure, so you need to make sure it's highly available and can handle a ton of traffic. Another popular one, pattern 2, is when the gateway sits at the edge and then it routes traffic to an internal load balancer that manages a specific group of services, like all the services that make up your checkout feature. And for really big global applications, you'll see pattern 3. A CDN, or content delivery network, sits at the very edge. It handles all the easy stuff like images and videos, serving them from a location super close to the user. Then, only the real API requests get passed down the chain to the load balancer and the gateway. It's a beautiful, layered approach. Okay, let's bring this all home. How do you actually decide what you need for your project? When do you reach for one tool over the other? Or both? It really just boils down to one simple question. What is the main problem you're trying to solve? And here's the absolute key difference. You need a load balancer when your main worry is about system reliability. You're thinking, how do I handle raw network traffic? How do I make sure my site stays up? How do I add more servers easily? On the other hand, you need an API gateway when your main concern is API governance. You're thinking, how do I manage all these different APIs? How do I handle security and authentication in one place? How do I simplify things for my client developers? One is about traffic, the other is about rules. And just one last pro tip before we go. A really common mistake people make is something called gateway bloat. It's super tempting to start adding all sorts of business-specific logic into your gateway. Don't do it. You want to keep your gateway as thin and fast as possible. It should only handle those cross-cutting concerns we talked about: security, routing, logging. Keep the actual business logic inside your services. This will keep your gateway from becoming a new bottleneck. So, next time you're architecting a system, take a step back and just ask yourself this: where is my real complexity? Is it in the sheer volume of traffic I need to manage, or is it in the complex dance of communication between all my different services? Hopefully, this explainer gives you a much clearer map to navigate that decision. Thanks so much for watching.